Welcome back, and I've got a really fun experiment to show you today, one that you don't need a physics laboratory for, and also one that I hope you'll try yourselves at home. So here's an experiment you might have seen before, but I'd like you to try it anyway. I'm going to take two thin strips of paper. So there's the first one, and we'll just make the second one. There we go. Going to hold up the two strips of paper close to each other, and they've got a gap between them. And then what I'm going to do is just blow down the middle. Do that again. And the rather counterintuitive result you get is that when you blow more air down the middle, instead of separating, the two sheets of paper move together. It's very strange, and it's going to need a bit of explanation. Some of you might know that I hold a pilot's license, and it's this effect which is used to cause lift in aircraft wings. In the case of the two sheets of paper, they stuck together. And in the case of an aircraft flying straight and level, we've got air going over the wings, and hopefully the air going over the top of the wing has a different effect upon it as the air going under the bottom of the wing, and that's what causes lift. In this case, the lift you were seeing was the two pieces of paper moving together. So this effect is called Bernoulli's effect, and it's a rather unusual one and not a particularly easy one to explain. I don't normally have an explanation right in the middle of the video, but I thought we might do that first. So one of the things that Bernoulli said is that if a gas or a fluid is moving faster, then the pressure compared to the fluid that isn't moving as fast is lower in the faster moving fluid. So in the case of the two sheets of paper, the pressure on either side of the paper is the same, it's atmospheric, because the air is doing the same thing. But if I create high velocity or high speed air downwards, then the air in the gap is moving faster and so has a reduced pressure in the gap, and the outside air pressure pushes the two pieces of paper in. In the case of an aircraft wing, the top of the wing has a slightly longer distance over it than the bottom, which means that when you fly through the air going over the top of the wing has to move faster to move the same amount of distance, and if it's moving faster, the pressure here will be lower than underneath, so the wing generates some lift. It's used quite a lot in suspension bridges too, long ones, that if I turn this the other way around, air going underneath the bridge has to get to the other side faster because it's a further distance than air going on top, so the lift is actually downwards. It causes the bridge deck to stay down and not start to fly up into the air. But we can have a lot more fun with this effect. So here's the fun experiment you can try at home. This is using Bernoulli's principle to make a ball levitate above a hairdryer. And I'll show you how to do it in a second. So what you need for this experiment is a hairdryer. And it actually doesn't need to blow hot air. I didn't ask Steph, but I've just borrowed it for the afternoon, so I hope she doesn't mind. This one has got two speed settings, and I find it works best, or at least it's more stable, on the lower speed setting, but you can experiment. It doesn't need to be hot air at all. The only other thing you need is a ping pong ball. So turn on the hairdryer, put the ping pong ball in the airstream, and experiment with how much you can move around the hairdryer and how much you can tilt it too. So let's have a go. So there it is levitating, and let's see what sort of angle we can turn it through. That's pretty good. You might be able to get it to go through an even bigger angle than that. So, time for a bit of an explanation. When the ball's hovering directly above the hairdryer, the physics is a little bit easier. The air's blowing upwards and forcing the ball upwards, and its weight is acting downwards. And when those two forces are equal and opposite, the ball will hover. Bernoulli's effect does play a little bit of a part because air's rushing around either side of the ball and keeping it stable from left to right. It's when you turn the thing through an angle that it gets a bit more complicated. And if you remember Bernoulli's theorem, you've got air rushing over the top of the ball, going a little bit further than the air going underneath the ball. And because it's going further, it has to go faster, and the pressure on that side of the ball will be a little bit less, creating just that little bit of lift and putting the ball back where it should. So you can turn it through quite a large angle, and it will still appear to levitate. So, an easy experiment to do at home. Why not get the bits and pieces out and have a go yourself and see how you get on? I've seen it done with large hairdryers and blowers. I've seen it done with leaf blowers, and I've seen it done using huge, great big beach balls as well. So you don't just have to use a small hairdryer and a little tiny ping pong ball. So I hope you found that interesting and that you try that experiment at home yourselves. Let me know how you get on. Keep enjoying your physics, and I'll see you next time.